Welcome back guys. Today we will solve a very famous leet code problem, that is sort colors. In this problem we have been given three arrays of integers 0, 1 and 2. 0 represents color red, where 1 represents color white and 2 represents color blue. We have to sort the colors where 0 will be kept first, followed by 1 and then 2, and we need to do these things in place sorting. That means we cannot use any extra space, and also we cannot use any library sort function. And let's see the test cases. You have been given two, 0, 2 and 1, where 0 have been kept first, then followed by all the ones, then 2's. We have to do the thing like this way. So the easy naive approach, one thing can come into our mind, that let's count all the zeros, all the ones and all the twos, and put inside them all the zeros, ones and twos one by one into the same array that has been given as the input. So the time complexity of this approach will be order of n, but there will be three traversals needed to do this task. So there is a better approach available, uh, which we call Dutch flag algorithm. This is a very famous algorithm. Suppose to if I describe you the algorithm, let's say there are three types of students in the class. One is the naughty student, and one is the good student, and one is the average student. Let's say naughty students will spoil the average students, right? So what we will do, what will class teacher will do, that they will separate the naughty student. Let's say we have naughty students, there is good students, there is average students. So what the class teacher will do, the class teacher will make sure the naughty students and the average students are kept at the extreme ends of the class. So they will be kept at the extreme end of the class, followed by the good students in the middle. We don't need to keep in mind about the position of the good student. If we make sure that naughty students and average students are at the extreme corners, then the solution can be achieved. So let's code this approach. It's a little complex thing, I know, for beginners. Let's compute the array. If the length, it's a h case, if the length of the array is 0, then just return it. Or if it's not, let's keep we need three pointers. One is low, and it is high, and another pointer I need is current. What the low point will do, low pointer will make sure, will keep indicate the position of the number 0, right? And the high pointer will be kept at the extreme end. It will make sure all the elements are kept, all the twos are kept at the extreme end, and the lows will make sure all the zeros will be kept at the front end, and followed current will be the indices that will keep on rotating through the array. Let's code this thing. My current will run from iterate from current to high. Let's say if nums of current equals to 0, that means it is a naughty boy, so I need to keep the naughty boy at the front end. So what we will do, we will swap. Now the naughty boy position will be denoted by the low pointer, so what we'll do, we will swap the current index with the low index, right? Now swapping has been done. Now you will increment the position. So if in future we'll get another naughty boy, we'll swap the naughty boy with these low indexes. And let's also make sure the current is also incremented. Now let's say average ones. No, sorry. Let's say the good ones. Good students are the one. I don't need to think about them because they will be kept at the middle. If we make sure the naughty ones and the average ones at the extreme end, then the good ones will be at the middle. So if good ones have come, we just make sure it is current plus plus. We will just keep implementing. We don't need to think too much about the good ones. Now it is time for the average ones. Now if average student has come, that is, we have encountered a something like 2. So what we will do, we need to swap. Now the average students have been indicated by the high pointer, So what we'll do, we'll swap the current with the high, that is this one. Now let's decrement the counter. Now the high is at the last 10. Now let's decrement the high pointer, but make sure we do not increment the current. Now why this is so? Let's say for a test case, let's say for a test case, 0, 0, 2, 2, 1. Let's say there are some ones, there are some twos. Let's say we have encountered, we are currently at the number 2, right? Now the high, let's say high is around, high is around the there is also, let's say 2. Let's say high, low is the current is here and the high is here. If we swap these two things, now 2 will again come, right? It will be swapped. Two here comes here and 2 comes here. It will be swapped. But the 2 is already here now. If I do current plus plus, then it will be missed out. So don't increment the current pointers. Just keep decrement the high pointers. That is one thing you must need to do. And now we don't need to return anything because it's a void. So let's test out the code. Sorry, I haven't written the, sorry, it should be high. Lot of typos in my code. Lot of typos in my code. Sorry, yeah. Oh, sorry, I need to write the swap function as well. Swap function, there will be two I and j. It's better to write a separate swap function because it will be too cluttered in one function call. So make sure your code is very clean and neat. Again, I have a typo. Sorry for that. Yeah, the two test cases passed. Let's submit. Yeah, it passed. So the time complexity of the solution is same, order of n. TC is sorry, order of n, and the space complexity will be constant. I didn't use any in speaks, and most importantly, I have done this thing in just one pass in single traversal. This is called Dutch flag algorithm. Just like why this is called Dutch flag algorithm, because in the Dutch flag you will see three colors are there. Three colors, let's say Indian tricolor has three colors. Let's ignore the Ashok Chakra. We have green, we have saffron, we have white, and we have green. So there are three colors. Now the saffron will be kept at the top, the green will be kept at the bottommost, followed by the white in between. This is the reason this is called Dutch flag algorithm. In the Dutch flag, there is also three colors. I have forgotten what are them. But we try to make sure saffron or green are at the extreme end, at the extreme corners, so that white is in the middle. We don't need to think twice about the white, because if we make sure saffron or green at the extreme end, then this thing is then white is already taken care of. This is why this is called Dutch flag algorithm. So this is it. It's an easy problem, but it's a very famous problem. So I tried to do this thing. Thank you. That's it from me.